Hub Academy, where we demystify conception in science. And again today, we want to examine some practice questions in chemistry in stoichiometry. MgO plus HCl gives us MgCl plus H2. What mass of magnesium oxide is needed to neutralize solidified CN cube of 0.1 mole per dm cube HCl? These are the parameters given. This is a question on stoichiometry, and there is a need for us to understand the simple conception required here. The first thing to do is to write down the parameters. So we are told to calculate the mass of magnesium oxide, which is what is needed in the question. So our MgO, mass of MgO, that's magnesium oxide, that is required. This is exactly what we are looking for. But what are the parameters given? We are given 25 cm cube of 0.1 mole per dm cube HCl. So we have the volume of HCl given as 25 cm cube. We are also given the molar concentration of HCl. So the molar concentration of HCl was given as 0.1 mole per dm cube or molar. So for us to therefore solve or estimate the value of mole, because there is a need for us to estimate mole so that we can do the comparison. Now, to get the mole of HCl, we're going to use the formula related to the molar concentration, because the parameter given is the molar concentration and volume. So we'll be using the molar concentration is equal to mole over the volume. So with this, it implies that our mole is going to be equal to the molar concentration multiplied by the volume. Therefore, the mole of the acid here will be the molar concentration of the acid, which is 0.1 mole per dm, multiplied by the volume. This volume has to be converted to dmp by dividing it by 1000. So that will be 0.025. 1, 2, 3. So it implies that the mole here will be equals to 0.1 multiplied by 0.025. 0.0025 here. Now, this is exactly the mole of the acid given, that is HCl. So we can then do the comparison from what we have here in the equation. So 1 mole of MgO is reacting with 2 moles of HCl. So the implication of that is that for every 1 mole of MgO, you have 2 moles of HCl. And the mole of HCl estimated here was 0.025. Now, from this, we can therefore say what mole, that is X mole, of our MgO, magnesium oxide, reacts to give us the mole of acid in the question for the reaction, that is 0.0025. So to give us 0.0025 moles of HCl. So from this, it's therefore easy for us to estimate the mole of MgO reacting in question. So we can put an equal sign here. So that will give us X. So we're going to have a cross multiplication sign here. Then we are going to have X mole of MgO will be equal to 0.0025 multiplied by 1 divided by 2. So it means the mole of MgO reacting in the question is going to be 0.00125. So from there, you can easily estimate the mass as it is required in the question. So the mass of MgO will be equal to mole of MgO multiplied by the molar mass of MgO. So the mole of MgO is known, right, to be 0.00125 multiplied by the molar mass of MgO. We can do that here. So we are given the atomic mass of Mg to be 24. So that will be 24 plus 16. So when you add both together, this plus this is 0, this plus this is 3, that's 4. So this is the molar mass. So from here, we count our mole. So from here, we can put the value here, and then the mass of MgO becomes 0.00125 multiplied by 40. What would that give us? 0.05. So this is the mass of MgO reacting in the question. So subscribe to my YouTube channel follow me for more content like this. We meet again in the next episode. Bye for now.